Okay guys, so today we're going to be talking about secant lines and angles, and the first thing I want to discuss is what exactly is a secant line. Well, a secant line is a line that intersects a circle and or figure at exactly 2 points. So you know the normal lines that we see that go through figures and only crosses at 2 points? That is a secant line. That's the name. It's called a secant line. And here's an example. AB is a secant line because it only crosses at point A and B, and line CD, again, is a secant line because it only crosses at point C and point D. Now we have 2 secant lines in this figure. If 2 secant lines, let's write this down, if 2 secant lines intersect inside or in the interior of a circle, then the measure of an angle formed is half the sum of the measure of the arcs. Intercepted by the angle and its vertical angle. That's a lot of information to throw at you right here, isn't it? That if 2 secant lines intersect, this angle is equal to half the sum of the 2 arcs. The 2 arcs added together. What do I mean by that? Well, let's look at it. We know let's look at angle 1 and angle 2. We know angle 1 and angle 2 are vertical angles, so they have to be congruent. We're going to set it up as angle 1 is equal to 1/2 the sum of the 2 arcs. Well, angle 1 creates this arc, AC. So, arc AC. Plus the measure of the arc of its vertical angle. Remember, vertical angles are directly across from each other, and they're made by 2 lines. The arc of the vertical angle, or angle 2, is DB. So the measure of DB. We're going to set this up. We know 1 is equal to 1/2 the arc, or the measure of AC, plus the measure of arc DB. So we're going to take our 2 arcs, add them together, and divide it by 2. Let's do an example. We want to find the measure of angle 1. We know angle 1 is equal to 1/2 the measure of the arc BC and its vertical angle's arc, or AD. We know AD is 20, and we know BC is 30. 30 plus 20 is going to be 50. Half of 50 is going to be 25 degrees. So our angle 1 is 25 degrees. Okay? Let's keep going. There are some other information that you need to know. We're going to write these down. First off, if a secant and a tangent As you guys remember, a tangent line is a line that only intersects the circle at one point. Intersect a point. A point of tangency. Let me rephrase it. A point of tangency. Remember, where the tangent line touches the circle, that is the point. Then, the measure of each angle is formed. Each angle formed is half the measure of the indicated angle. Half the indicated angle. Let me rephrase that. Half the indicated arc, not the angle. That messes it up. Arc. I apologize. I am a little bit slow today. So let's start with another example. Okay, so what do I mean by this? Let's start with it. We know the measure of angle ABC is going to equal 1/2 the measure of arc ADB. So let's work this question out. If I were to give you something like this one is 102, let's find the measure. We want to find the measure of angle ABC. That's what we're going to start with. We're going to find the measure of angle ABC. Well, first off, we know the angle A, or the arc of AB, is 102 degrees. We need to find the measure of the arc ADB. We'll start there. Well, we know the whole circle is 360 degrees. So we're going to set up as 360 minus 102 to equal the measure of ADB. 360 minus 102 is going to be 258 degrees. We still want to find our ABC. And it is 1/2 the measure of ADB. We know ADB is 258. So the measure of ABC has to be 1/2 of 258. If we take 258 and divide it by 2, it gives us 129 degrees. So the measure of our angle is 129 degrees. Okay, we're going to keep going. There's a little bit more to talk about. We're going to be talking about two secant lines creating an angle and a secant and a tangent on the exterior. So right here we were talking about interior, or directly on the line. Now we're going to be talking about exterior. So let's start. If a secant, if two secants intersect in the exterior of a circle, the measure of the angle is 1/2 the positive difference of the measures of the intersected arcs. And again, that sounds really intense. So let's draw it out to show what this means. So we have two secant lines and they intersect on the outside of the circle. This is going to be A, B, C, D, and E. The measure of angle A has to equal 1/2 the larger arc, or DE, minus the smaller arc, or BC. That's all it means. The bigger arc minus the little arc divided by 2 equals our exterior angle. We know it's exterior because it's outside of our figure. Let's do an example using this rule. Okay, so we're going to use the same rule to solve for this one. We know that our exterior angle is angle C, and it has to equal 1/2 the measure of the larger arc, or EA, minus the smaller arc, or DB. Well, we know DB is 50, and we know EA is 120 degrees. (120 minus 50 is going to be 70. (70 divided by 2 is going to be 35 degrees. So for this one, it's going to be 35 degrees. Now we do have one more rule I want you guys to remember. No, wait, that's the last rule. That's the last rule. We're just going to go over examples of mixed, well, there's one more rule, actually. So a secant and a tangent on the exterior is going to follow the same formula here. So a secant and tangent exterior is going to follow the same situation. We're going to start with our circle. This is our tangent line. That is our secant line. D, B, A, and C. Angle A has to equal 1/2 the measure of DC minus BC. Okay, same rule, different way to look at it. We're going to do a little bit harder example of this one because it's still going to be the same rule, just a different look. Let's do this question. And we're going to do 2 tangents after this one, following the same rule. Give me 1 second.